about assessing the effectiveness of your security. There's a lot of bugs in code. It's 15 to 50 errors per 1,000 lines of code. It's a fairly common number. There was a study a while ago that showed that commercial code like Microsoft Windows had a lot more errors than open source code like Linux. But anyway, there's a lot of errors in code. You will never get rid of all the errors. So there's a lot of vulnerabilities. You can have hard-coded credentials like passwords or API keys. You can have buffer overflows where you make a container for data in a language like C and you put too much data in the container. SQL injection, where you put in code that is misunderstood and executes an unexpected command on a database. Path traversal, where you're supposed to refer to a file name and you're able to redirect it to refer to a different file that you're not supposed to be reading or writing to. And remote file inclusion is PHP's vulnerability, where that's where it refers to a file name and you get it to read or write to the wrong file. Directory path traversal is similar. So like I say, buffer overflow, this is particularly due to C. C would reserve space for a name with 20 characters this way, and then if you tried to put in 30 characters, it would not stop you. Higher level languages like Python would prevent that, but C won't. And Rust is rapidly gaining as the superior language, which is fast and low level like C, but which does notice mistakes like this and prevent them. Race conditions are where there is a time of check and a time of use, and those are different. So you put data somewhere, and then you come back later and read it, assuming it has not been changed, but there is some possibility that it has been changed, and therefore an attacker can win the race by changing something in the brief period of time between the time of check and the time of use. This is often used for privilege escalation attacks, where something happens at a high privilege briefly, and then it's supposed to go back to a low privilege to go back to the user, but the user has some way to sneak in a command which executes during the period of time when it has high privilege. Cross-site scripting is where data comes from a user on a website, and it's only supposed to be static data like a name or address, but they're able to add code to it which runs in the browser of the viewer. So unexpected code runs on your website that was not put there by the developer. Beef is a framework intended to make this easy. I think it's kind of out of date now. The cross-site request forgery is a similar attack where you put code that will execute a command. For example, you could put an image tag on a website which now tries to load a page, and this tries to call a script that will transfer money from one account to another. So if somebody just views the web page, a request will come from their browser as if they had clicked on it to go do something, like an action on some other service like Facebook or Amazon. And if it works, you will trick them into doing an action they didn't intend to do on some other site, because the browser will automatically send their cookie up and authorize it, or you could do it by stealing their cookie and sending the request directly from your machine with the stolen cookie. Privilege escalation, I mentioned, this is where you elevate yourself. You're a normal user, but you elevate to administrator or root. Horizontal escalation is where you move from your account into somebody else's account, even though you are not authorized, you don't really have their username and password. A backdoor is a shortcut into a system. This used to be very common. Cisco got caught doing this 8 times in 1 year, about 5 years ago. They would ship a product that had a secret password in there that they didn't tell you for like the tech support to use. This used to be very common 20 years ago. It's no longer considered a good practice. And but there's developers that have old techniques and do leave secret backdoors into things. So when you find a vulnerability in a product, then there's an issue of disclosure. If they have a bug bounty program, then you can join the program and issue an official comment to them through the official channels, and that's nice, but only the more professional, experienced companies have bug bounty programs. The ones that don't, you have a problem. If you find a vulnerability, you could do full disclosure by just putting it on Twitter or something, and then innocent users might get hurt while it takes time to patch it. And then there's this thing called responsible disclosure, where you tell the vendor privately and give them time to patch it. The capability maturity model from Carnegie Mellon is a way to create quality software. And so you've got these are a way to rate the quality of your development process. So the initial level is where you just have ad hoc and chaotic, where just individual people just write code and it isn't really managed or organized very well. Then there's basic project managed, where it's repeatable and then defined where you have it standardized, processed, managed where you actually measure the quality and control it, and then optimizing where you measure, not only control how the stuff is developed, you then measure to see how good it is and improve it and go through another, so you constantly, continuously improve it. And these are the levels of maturity of software development. Acceptance testing has similar levels of, to decide how good something is. User acceptance means that the users can use the product and it's good enough. Operational acceptance means it works. Contract acceptance means it fulfills the conditions of the contract. And then compliance means it meets some kind of compliance standard. So commercial off-the-shelf software can have a security impact, and this is a huge issue now. Every time I do Pulse Security Weekly, there's a bunch of information about software bill of materials and supply chain attacks. Everybody is very worried. You get software, and the vendor claims it has certain products, but how good is it? Well, there's third-party research. Vendors might go out of support. There's service-level agreements and so on. When you're trusting other people's software, this can put you in trouble, and yet you have no real choice. You can't write everything yourself, so it's a problem. And then, of course, artificial intelligence, huge these days. Very little of it's in the CISSP exam because it's kind of old, but it's exploding now, of course. So expert systems has a knowledge base. This is one way to do it, where you just have if-then statements and then an inference tree. This is an old, you'd write a chess program that just has rules, like move this, if a certain try to maximize some number. This is the old-fashioned way to do it, where humans specify what it's going to do. But in artificial intelligence system, it learns. You do not write. So that's why I said in the news part, a question with ChatGPT is if it makes a decision, why did it make that decision? And you can't say. What happens is you feed in stuff like pixels from an image into neurons, then they go to other neurons, and they come to an output, which will make a decision like, is this a car or is this not a car? And when you say, why did it misidentify this thing as a car? There's not one neuron that made that decision. All these things work together to make that decision, just like all the cells in your brain work together. And you don't really know, but you train it. You give it a bunch of input data and just train it until it gets good at it. And then you can use it, but you don't really understand how it works. Bayesian filtering is a simple process where you just look for certain words in spam versus good mail. This is an old-fashioned technique of spam filtering that turned out to be very ineffective. And then there's genetic algorithms and programming. There's some that will create random programs and then execute them and decide how valuable they are and then combine them with each other like sexual reproduction to make another generation. This is one of the many ways to do artificial and machine learning. The most common form, and the kind that I'm doing on my extra credit projects, is this kind, where you have a fixed structure, inputs going to nodes, and all you're doing is adjusting the weights of these various nodes, which is very close to what your brain does. This is what's used by ChatGPT in most modern systems. All right, so let's try the HC Kahoot. All right. She has a comment in financial area. Someone uses tech similar to GPT to make financial news more brief. Yes, this is a big issue. I hear people using ChatGPT a lot to make things like advertising material and presentations to like a board of directors. It's very good at taking a pile of stuff and turning it into, like a bulleted list or a PowerPoint presentation or something. I've used the one where it can look at a whole hour-long video and it can boil it down to like a few paragraphs summarizing what's in this video. I find that very useful. Works pretty well in these lecture videos. That's what I tried it on. It can totally turn all these lecture videos into like a few paragraphs summarizing what was covered in that lecture. So if I were selling this stuff, and like advertising the course, a ChatGPT generated summary of the videos would be good promotional material. Pay $10, view this video, here's what's going to be in it. I can see why it's very valuable there. Okay, which one is a flaw in C? Buffer overflows are specifically caused by the way C handles strings. Other languages prevent this. All right, which one is a race condition? Time of check, time of use. That's a race condition. So which risk might cause the user to perform an unintended action, like ordering a book? That's cross-site request forgery, where they trick you into performing an action you did not intend to perform using your stored credentials. All right, and which one is Carnegie Mellon's software quality framework? The capability maturity model. All right. All right, so it's won all 3 times. And Sarah Damien. Good. All right, that's it. That's the last chapter, so I'll stop this.